Hey everyone, welcome to the Lesson 7.8 Dividing Polynomials screencast. So this is going to get a little bit crazy for a minute, but really just got to learn the procedures. So we divide polynomials using a method similar to long division. So let's review long division first. So let's say you have 200, here we go again with this box, 246 divided by 7. Okay, some vocabulary. This is called the dividend. This is called the divisor. Okay, so when we set it up to do long division, we set up the dividend in the little house, as we used to say in like 3rd grade, and the divisor outside. So again, this is dividend, okay, it would help if I could spell. Let's try that again. Dividend and divisor. Okay, so long division. 7 goes into 2 how many times? It doesn't. We leave that space, and so 7 goes into 24 3 times. So there's our 3. Multiply 7 times 3, we get 21. We subtract. 24 minus 21 is 3, and we bring down the next term. 7 goes into 36 5 times. 5 times 7 is 35. We subtract, and we end up with this number down here, which is now called a remainder. This number up here is called the quotient. Okay, so for our final answer, we would say 246 divided by 7 equals 35. Remainder 1. We now would put that over 7 and say 35 and 1/7, and really for our purposes we're not going to see many remainders. They do happen in dividing polynomials, but because we're going to be using division of polynomials to solve higher degree functions, we're not going to see many remainders. If you get a remainder, in fact, it's not a great thing. So remember, when you get a remainder, that means that 7 here, in this case, is not a factor of 246 because we got a remainder. The remainder should be 0 if the 7 is going to be a factor of 246. Okay, so just a little refresher for long division. Let's see how it's related to dividing polynomials. So we have the same setup for the problem. 6x to the 3rd plus 11x squared minus 17x minus 30 divided by x plus 2. So same thing. This is the dividend and this is the divisor, which means the dividend goes in the little house. So 6x to the 3rd plus 11x squared minus 17x minus 30, and the divisor goes out front. Okay, so here's how we figure out how we divide polynomials. We're going to start by taking I'm going to start by getting a highlighter here so that I can hopefully help with this stuff. So let's try this. Okay, so we're going to take the first term just like we did in the long division. Say, okay, 6x to the 3rd, and we're taking, really just focusing on the x out front here. So the number or variable that I put up here is going to make 6x to the 3rd when I multiply it by x. Okay, so let me say that again. So x times whatever number I put up here should equal 6x to the 3rd. So what would that number be? Well, it's going to have to be 6 so that I get 6x. And x times what makes x to the 3rd? That answer is x squared, because x times x squared gives me x to the 3rd. So I multiply. So I have 6x squared times x. So just like we did with the 7, we multiply. So that gives me 6x x to the third. But now there's the other term here as well. So what I have to do is also multiply this term. So I have 6x squared times 2. Well, 6x squared times 2 is 12x squared. And notice when I write them down here, I line them up with their like terms. Oh, excuse me. Okay. So again, just like in long division, once you take your number, you multiply it and write that down here, we subtract. Same thing applies to polynomials. So I have to subtract these things. So remember, when we subtract, we change the signs. So 6x to the third, we change subtraction to addition. This becomes negative. Positive 12x squared becomes negative 12x squared. So subtract it down. 6x to the third minus 6x to the third cancels. That's exactly what we needed. So there's nothing here. 11x squared minus 12x squared, that's negative 1x squared. And then just like in regular long division, we bring down the other terms that are left. Okay, and we do it all again. So now, what number times x will give me the 1x squared, actually negative 1x squared? So that would be a negative 1 times x. So negative 1 times x, negative 1x times x is negative 1x squared. And then you have to do the negative 1x times positive 2, so that's negative 2x. Remember, we are subtracting, so I'm subtracting, change subtraction to addition, change the signs. So negative 1x squared plus 1x squared cancels, just like I needed. Negative 17x plus 2x is negative 15x. Bring down negative 30. Go again. Negative 15x. I have to make negative 15x multiplying by x. X times negative 15 is negative 15x. So I make negative 15x. I also have to do negative 15 times positive 2, so that gives me negative 30. And I subtract. Again, subtraction, change to addition, change the sign. So negative 15x plus 15x cancels. Negative 30 plus 30 gives me a remainder of 0. Okay, so what do we do with this whole thing? What did we just find out? So first, let's just point out that the remainder is 0. And then I'll make a note of that in a minute and tell you what that means. But let's actually write the solution. Right? So we just found out that 6x to the third plus 11x squared minus 17x minus 30 divided by x plus 2 equals, here's our quotient, here's our answer. It's equal to 6x squared minus 1x minus 15. Okay, so I'm going to go to the next page and actually write out the answer. So 6x to the third plus 11x squared minus 17x minus 30 divided by x plus 2 equals 6x squared minus 1x minus 15. Or you could say 6x to the third plus 11x squared minus 17x minus 30 equals 6x squared minus 1x minus 15 times x plus 2. All I did was take the x plus 2 from here and multiply both sides by it, so it would cancel from the left side and multiply the right side. That's another way to write your solution. Okay? So, since we have a sentence we're going to write here, so get that down, and then I'll go to the next screen. Pause it if you need to. I'll go to the next screen. So here's a little sentence I want you to fit in that section. Since the remainder is 0, then x plus 2 is a factor of the polynomial 6x to the third plus 11x squared minus 17x minus 30, and negative 2 is a root of the function. Okay, so how do I know negative 2 is the root? Well, remember, if x plus 2 is a factor, then I set it equal to 0, and then I solve, and x is equal to negative 2. So if x plus 2 is a factor, then x equals negative 2 is a root. And we're going to use that for the back of the screencast, which is synthetic division. Before you do that, though, on the bottom, there's a spot for you try. So something a little bit different. So the problem I would like you to try is 3x to the third plus 22x squared plus 38x plus 15 divided by x plus 5. Okay, so I'm not going to screencast this as a solution. I want you to try it, bring it into class, worked out. You should get a remainder of 0, I'll give you that much. So I want to see you try the solution and see what you come up with, and then we'll talk about it the next time I see you in class. Okay? So that's your you try there. Okay, so on the back, when you can pause, okay, do your you try, and then when you're ready, go to the back. So on the back it says synthetic division of polynomials. So mathematicians have created a faster system than long division for dividing a polynomial by a binomial. So we'll do the same problem that we did again in the example, but this time we'll use the faster system called synthetic division. So here's for synthetic division. So you have the same problem, 6x to the third plus 11x squared minus 17x minus 30 divided by x plus 2. So again, we just talked about if x plus 2 is a factor, then negative 2 is a root and should divide evenly. Okay, so here is the setup for synthetic division. It's a little strange, and the procedure is a little weird because we're going to do a bunch of practice on it, not through the screencast obviously, but you see there's another you try there for you. So here's how I'm going to set it up, and then I'll go to a new page to actually solve it. So here's the setup for you. Outside, we draw like a little, it's like an upside down division sign. We put the root outside here. So this is the root. It's negative 2. Remember, it's the opposite of what the factor is. So the factor is x plus 2. We solve that equal to 0 to get the root, so the root is negative 2. Okay? I'm going to have to erase this note that I put here because I'm going to run out of room. So make sure you write that down and then get it out of the way. Okay. Right next to the root, inside this half of a rectangle, we're going to put the coefficients of the dividend. Okay, so coefficients of dividend. So the dividend, remember, is the top of the fraction. So just the coefficients. So 6, 11, negative 17, and negative 30. Okay? So here's how this works. This doesn't really take up all that much room, but because I want to put some notes in here with it, I'm going to go on to a new screen. Okay, so you can keep the whatever you have working, but I want to get this up to the top of the screen so that I have some room to add some more notes for you. You don't have to rewrite what I'm about to rewrite. Okay, so -2, then we have 6, 11, -17, and -30. Okay, so after our setup, we have to bring down the first coefficient. So this is the procedure for solving it. So after setup, which we just did, then 1, bring down first coefficient. So all I'm doing is dropping this 6 straight down to here. Okay. Second step. Multiply by the divisor and place under the next coefficient. So multiply by the divisor and place under next coefficient. So I take the 6 and I'm going to multiply it by the divisor. The divisor is -2. So times -2, and then that answer is going to go right under the next coefficient. So this is -12. Okay? Third step, I'm going to bring that over here because I know that kind of cuts off that corner. So third step is add the column. So now I'm going to add straight down here, 11 plus -12, that's -1. Okay? So this little pink arrow, if you can fit it in there, maybe write add. So we add that down. And now we just repeat. So step 4, repeat. So I take now my -1. -1 times -2, that goes over here, so times -2, that's a +2. And we add -17 plus 2 is -15. Okay. Then we come over here, multiply by -2, that's a +30. And we add -30, +30, and there's our 0. So here's the remainder. And here is our answer. Okay, it looks very strange. Now I'm just taking the 6, the -1, and the -15. So that's our answer. It's a new polynomial with 1 less degree. So what do I mean by that? Well, flipping back, here, this polynomial was third-degree polynomial. Yes, agreed, because of the exponent 3. So this polynomial is going to be 1 less degree. So it's not going to be third degree, it's going to be second degree. So the first term is going to have x to the second. The second term is going to have x to the first. And the third term has no x. And here is the answer using synthetic division. Notice, if I go back to the long division problem, same answer, 6x squared minus 1x minus 15. There it is, 6x squared minus 1x minus 15 Synthetic division, 6x squared minus 1x minus 15. So it all works out through the same way. Okay? So, again, I would like you to try that same problem from before. So you're going to do the same thing I did, 3x to the third plus 22x squared plus 38x plus 15 divided by x plus 5. So this is the same thing. This is the you try. Just like I got the same answer for long division and synthetic division, you should get the same answer for long division and synthetic division. Okay, just try it out. You'll get full credit for giving it some thought and some effort. If you're not going to do the you try, you're not going to get the full credit for the homework, so make sure you at least try it. Go back and re-watch my example again if you need to, or pause it and try it that way. All right? And any questions that you have, because I know it's a little bit crazy, definitely something new. So any questions that you have, I will be glad to answer next time I see you in class.